dude, what's going on?
Just some Chapter 2 geometry.
Oh, need some help?
Well, no, not really.
Oh, so let me help you out. All right.
Okay.
Oh, look, conditionals. You know, if-then statements.
Yeah, I'm reviewing for the finals.
Oh, so you don't? It's like this. If P, then Q. So for example, if 4x equals 20, then x equals 5.
Yeah, I know.
Oh, so you don't understand? Well, let's look at it this way. The converse, which is the statement flipped. So, like this. If Q, then P. But let's flip my example. So, if x equals 5, then 4x equals 20. And now your conclusion becomes your Q. But what if you can prove that wrong, you say?
No, I didn't say that.
Oh. Well, that's called a counterexample.
Sure is.
That's where biconditionals come in. A biconditional is written like P if and only if Q. So for example, segments are congruent if and only if their lengths are equal. Pretty easy, huh?
No, it was made on.
Dude! Oh. We're not done! Now to properties of algebra. First is the addition property and the subtraction property. So it's like A plus B is equal to C plus D, or A minus B is equal to C minus D. But there's also multiplication and division property, which works the same way. If A equals B, then CA equals CB. And in division, if A equals B and C does not equal 0, then A over C equals B over C. But there's this other equation, and it's pretty crazy. If A equals B, they can be substituted for each other in any equation or inequality. But that's a whole different story, right? Uh-huh. The next property is the reflexive property. Here's the reflexive property. A equals A. Do you like trains? I like trains. So this leads me to my next property, the transitive property. If A equals B and B equals C, then A must equal C. There it is. It's pretty interesting, am I right? Huh? Shoot. Where can it be? I hate the heat so winter weather, the bed and empty sign. No oasis in the sand is singing deathless words to me. Can't you help me as I'm starting to burn? Too many doses and I'm starting to get in a So the next step is how to write a proof. What you do is draw a line down the middle, and you write statements on one side, reasons on the other. The reasons on the right side are those properties I showed you, remember? And theorems and postulates. But we'll get to postulates later. But let's move on to theorems. The midpoint theorem. If M is the midpoint of AB, then AM equals half of AB, and MB equals half of AB. The next theorem I have to show you is angle bisector theorem. Angle bisector theorem. If ray BX is the bisector of angle ABC, then the measure of ABX is half of the measure of ABC. And the measure of XBC is also half the measure of angle ABC. The next thing I have to show you is complementary and supplementary angles. Oh my god, is it exciting! Complementary angles are two angles that add up to 90 degrees. And supplementary angles are two angles that add up to 180. It's so exciting! Yes! Are you listening to me? Oh my god, it's so... The next thing I have to talk about is vertical angles. Oh my god. It's when two angles cross like this, and then it's this and this angle. This and this one, this and this angle because... Well, in case you didn't understand the video, it's this one and this one. These two are vertical angles. So the next thing I have to show you is about vertical angles. And it leads me to my next theorem. Vertical angles are congruent. This and this one are equal. This and this one. This and this one. And this one and this one. And this one and this one. Alright? You got it? Vertical angles are congruent. The next thing I have to tell you about is perpendicular angles. Well, they look like this. And this side is 90 degrees. And this side is 90 degrees. Do you get that? Are you listening to me? Ah, good. Alright, so this, it looks like this. And they cross at a T, or they make a T, or something like that. Like this. Yep. And all angles are 90 degrees. Talking about perpendicular lines leads me to my next three theorems. So the first one is, if two lines are perpendicular, then they form two adjacent angles. And if two lines form congruent adjacent angles, then the lines are perpendicular. This next one is a mouthful. If the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. Get out! Ah! Oh, good. You're done. So this leads me to my next two theorems, and they both have to do with complementary and supplementary angles. Supplements of the same angles or congruent angles are congruent. So, if angle 1 and 2 are congruent, and the measure of angle 1 plus the measure of angle 3 equals 180, then the measure of angle 2 plus the measure of angle 3 equals 180 also. The next theorem is, complements of the same angle or congruent angles are congruent. So, if the measure of angle 1 is congruent to the measure of angle 2, then the measure of angle 1 plus the measure of angle 3 equals 90. Also, the measure of angle 2 plus the measure of angle 3 equals 90. Woo! That was a lot of stuff in chapter 2. I mean, I hope you learned a lot, because you know what? I sure did when I did all this. So you know what? That was all chapter 2. So, now on to chapter 3, okay? So,
No more chapter 3, no more lessons. You're getting out of my house. The last time, you're meddling with my life.
What are you doing? What are you doing? Ah! What about chapter 3?